can you imagine the fact that somebody who has never seen before in their lives, that can wear the glasses and see what the outside world is? That's very, very mind-blowing. If such attention was actually like steered towards hardware, I feel like Nigeria would have been a better place than it is at the moment. It just buy components because they've seen somebody use it on YouTube, and by the time they want to deploy it in their projects, I know a lot of companies in this, but apologies.
So you guys the way shading us now.
Did you check the specification, my dear? Oh, sorry, I'm a computer. They need to talk about specification.
Hi everyone, welcome to another exciting episode of Beyond Code, the podcast where we talk about all things tech and beyond. Today we'll be stepping away from the world of software engineering and diving into the world of hardware engineering. And who else is the best person to take us through hardware engineering if not our very own president, the president of IEEE OAU, and is also a very good hardware enthusiast. So join me as I welcome Emmanuel Peters to Beyond Code. Hi Manuel.
Hello, Mercy. Yeah.
How are you doing?
Fine, hope you're good.
I'm good.
It's a pleasure to be here.
Thank you. We are very excited to have you here. First of all, I went through your LinkedIn bio, and oh my God, Emmanuel, please, you have to tell us what inspired your thoughts and everything in that LinkedIn bio.
Okay, so my LinkedIn bio is actually a very, very funny story. So there's this colleague of hers who is currently in the United States. So I had to like pour through his LinkedIn bio, and I saw the way he crafted his LinkedIn bio. So it was very, very interesting. Not the way a secular LinkedIn bio looks like.
It's not
so, exactly. So that was what motivated me to also like follow the same style, so that people read whatever I put out there, and yes, they are very much interested.
I said if I was a recruiter like this, I'm going to definitely read this to the end. So very good. So I told you that we should use your writing skills and since in fact is
no problem.
Whenever you are ready, just let me know.
Okay, very well.
Okay.
I'll always.
So in OAU campus, we all know, even in Nigeria, technology is like just thriving and coming up, and everybody's going into technology. But then we have this aspect of you that everybody is going into software engineering, non-technical skills, fintech, and then so how did you what inspired your interest into hardware engineering?
Okay, so it's actually a long journey, more like it. So I could remember then as a secondary school kid, primary school kid, so I was always fascinated by one particular electronic device, which is actually the radio. So oftentimes I used to wonder, how does this thing make those sounds? Who are these families residing inside this radio? I think one of these days I really want to join them as well, so that exactly. So that was what I felt like. And entering SS1, and I just knew that we are talking about transistors here, just resistors. A certain arrangement of them gives us those particular things we're actually talking about. And the limit of anywhere I can actually travel to with that particular radio is how far I can tune the radio. So it's within the rate of the range of tunable possibilities that I can actually get to wherever I want to. So it was just mind-blowing. It was very, very mind-blowing to know that somebody can be somewhere far off and still communicate their thoughts with me in real time. So it's not just some families residing inside the radio. So entering the university was another game changer, because yes, I put in for elect and we entered the elect that way big time. But there was nothing too electronic about elect other than the whole mathematical part. So it was just more of doing Laplace transform, Fourier transform, and everything. And it was just like, Emmanuel, you are never going to get your hands dirty with hardware or whatever I wanted to do. So I could remember my first point of contact with hardware was learning C programming. So there's this guy from computer science, Caleb Adewale. Yeah, he's like a great mentor, big time. So Caleb taught us C program because we were preparing for IEEE Extreme that year. And yeah, my first class during SWEP, which is like student work experience program, I was there, and there was this lecturer in our department that gave us an assignment to write a code that can blink 4 LEDs and giving each of them 50 milliseconds interval. So nobody did the assignment the following day, and we're right in the class. And the whole fear of hey, who will do this assignment, who did not do this assignment. So everybody was just stubborn and everybody was just getting new into Arduino programming and the whole hardware thing. So the lecturer entered the class and he was like, yes, I give you guys an assignment yesterday. Who has done that particular assignment? Nobody stood up. So the man was like, he's going to convert it to test. And from the experience of test, if you are not with Shano in the class, you don't bang down.
And so your first, okay, not your first year.
That was my second year actually.
Second
I was going from 200 to 300, so that was during SWEP. So everybody was like, so there was this friend of mine that knew that I had interacted with C programming. He just raised up my hand that, okay, yeah, I think we can do this. And that was my first time of writing an Arduino program on the board. So I was able to relate with the task and the whole software part of the task. And that was my first time of writing an hardware code, more like it, on the board. So I used the marker, wrote everything, and the lecturer saw it and was like, okay, so let's run this thing. I was very scared though, make them not spoil my steeds, and it worked. So ever since then, I've been really fascinated by the fact
now
that
I cannot do my
exactly. And from there, I actually transitioned into that. My first project was actually on a fire detecting system. So IoT based fire extinguisher and detecting system. So I was able to like communicate my whole idea from software, put on the hardware, and it was very smooth. And honestly, the fact that I could think about a problem and be able to breathe life to something, to electronics, and arrange them in some sort of ways, and it's going to give me the result I want, is very mind-blowing.
So you started from software engineering to then you dive into hardware.
Yeah.
A lot of us, we enter into school, like we get admission into computer engineering, we want to do the hardware stuff, want to like create something new and get our hand dirty. But then when we come to school, because of most of our peers, they are doing the software, our seniors are already making, so person has traveled out, this person is a front-end engineer, this person is a software engineer, and this one is like we hear a lot of doings from the software engineering aspect. So why do you think hardware engineering does not get the same attention that the software engineering gets?
Okay, yeah, thank you so much. So I feel like it's actually the rave of the time, more like what I'll call it, because if we should backtrack to history, when the whole hardware thing started with I think the first time people were really much crazy about hardware thing was during the era of Steve Wozniak, the CEO of Apple then. So when he created like a small PC and it really sold out, and that was just some crazy experts from his end. But now moving forward to our age, I would say one of the things I've actually noticed is that the cost embargo of hardware, because oftentimes you want to do some crazy projects, but by the time you see within your local environment, you're unable to get those products from your local environment, and even if you want to get those products, they are very expensive. You are not able to get them. And the other thing is the fact that there's a very low percentage of interest when it comes to people who are really pushing out this hardware thing. So you see, even people that are pushing out hardware, it's more like we are talking about the software part of hardware, not the core hardware where people get to get their hands dirty and a lot of things.
Someone said something like, you think this is true? Because we have more software applications than hardware applications. Like hardware, if you have one hardware device now, you can have several software applications. So the need for software applications are more than.
But I would say the fastest way of actually becoming a billionaire is actually having your own product, your own products. Now look at someone exactly in the hardware format. Now look at someone like Elon Musk. You see that this guy is just entering every single field, and he has a product that is actually selling, a physical product that is basically selling. I see that from that product is actually delving into software and taking everything. But if you look at the largest chunk of his products are actually hardware products. Now look at, there's one of his products that even really fascinates me. That's more the blind sight glasses, more like it. So it's just redefining the whole technology landscape. Can you imagine the fact that somebody who has never seen before in their lives, somebody was born blind and their optical nerves have been ruptured, the person can wear the glasses and see what the outside world is? That's very mind-blowing. I don't think software can really get you to that level. So you need to build something that can help you to visualize your dreams well, and that's where hardware comes in. So entry barrier is quite crazy. in terms of costs. You don't have, the hype is not on it because obviously it's not something that I can get by the roadside and just start building with time. So
I think the hype was not on it because it's not quite popular in Nigeria.
Well,
maybe if we are coming up to.
Actually true, because I remember attending my first tech event as well. That was like, I saw Ocean Girls Can Code. So yeah, that was the whole event. You see girls coming up with products, they were pushing out like, I will build this, have this and this and that, I will do this thing. So I actually really felt challenged that if such attention, UNICEF actually sponsored that particular program. If such attention was actually like steered towards hardware, I feel like Nigeria would have been a better place than it is at the moment.
Maybe
because
we will have our own products too.
Exactly,
Products.
Products that solve problems, in especially when it comes to air pollution, environmental pollution. All those places are areas where you cannot just deploy software. You need like something physical to be able to solve this problem.
And when people see the costs, they run away. Like the cost that is currently at the back of my head, you know. So let me so I'm going to, I have like 3 myths. Okay. I don't even know if they are myths or facts. So you are going to clear it for us.
Okay. Yeah.
If they are myths or facts in hardware engineering. So in case people, our viewers are watching, they want to get into hardware engineering and they've heard this before, and that's what is making them like run back and go back to software. So myth number 1, you need to be a mathematics genius to excel in hardware engineering.
Okay, that's false. Yeah, not a mathematics genius. All you need is a brain that can think, actually. Yeah. It's somebody,
all of us can think.
Exactly.
So that can be
so you don't need to be a crazy. Oftentimes in hardware engineering, you don't really do core. Like nobody's expecting you to differentiate, to integrate, and do some very crazy. We are doing Laplace transform. Nobody's expecting you to do Laplace transform whenever you are doing hardware engineering. So basically, it's a workflow of more like you get a particular product, you get the components, you have a problem you want to solve. Based on that particular problem, you go online, you check which of the products you have. So, but I would say the basic requirement is you should know something about electronic engineering. More like your physics.
Engineering.
Exactly. Oh, yes. Wow. I get your angle. Yeah, shall know something about the engineering that deals with electronics. I'm saying it in another time. So yeah, just know something about it so that by the time you are getting components, you understand the specifications of those components, because a lot of people do this blindly. They just buy components because they've seen somebody use it on YouTube, and by the time they want to deploy it in their projects, I know a lot of computers in this, but apologies.
So you guys see the way shading us now. Don't worry. So they are just jealous that we are now in faculty and they are still
so by the time they get the products and they are like, wow, this is not working as it should be. Did you check the specification, my dear?
Did that.
Oh, sorry, I'm a computer. They need to talk about specification. Yeah, that's pardonable. But that's actually the basic thing for you to be able to take a component, check the specification, check the data sheet, and can it actually do what you actually wanted to do. If it can, then you move on to understanding how that particular component works, then deploy it in your project.
Or ask somebody like Emmanuel.
Mercy is your best fit.
Myth number 2. Yeah. Hardware jobs are scarce compared to software jobs.
Wow, I would say that's a myth actually. So it's not true at all, because I could remember when my lecturer taught us VHDL then. So everybody was just crazy that where do they apply this VHDL thing? Like exactly, Dr. Kimali has taught us. By the time everybody went to LinkedIn and bro, just type VHDL, systems engineer, automation, a lot of, especially PLC, programmable logic controllers. You see a lot of industries using those things, and they need people that really understand hardware description languages to program those things. So the fact that we've been taught in class and you understand what these things do, so the jobs are just immense.
I feel like the software side are like saturated on the hardware side.
Exactly, because it's a niche that most people are really shying away from, because they think that it's like it's very technical, it's esoteric. Exactly. The hard is not for the kind of hard. It's the fact that I can touch it, I can hold it physically. That's what is meant by the hard. It's not the normal secular hard. So there are so many job opportunities, internships. Like I think that should be like 2 months ago. Somebody even reached out to me on LinkedIn that they had an internship offer for me. I mean, the person basically scanned my profile on LinkedIn and was like, okay, Just
You can go through his
so many.
His LinkedIn pages.
So many approaches.
I mean, on LinkedIn. He doesn't want us to
it's
talk
not
about
like that.
but just go and check it for yourself.
It's not like that. So
the person that is in
it's not. We're about to know he's not. So yeah, keep up the wine.
I'm not whining. Okay. So myth number 3: hardware is outdated, and the future is all about software. Like Nigerians will say, software is the new oil money.
Wow, sweet. Now, if you say the future is outdated, so I'd like you to look at a company like Nvidia. So, what does Nvidia basically do? What they do is they basically they produce hardware products for certain software implementations. Now, you see that the future of artificial intelligence, machine learning, data science has moved beyond just buying a type of computer. You need a computer with a particular computing power, some specifications before you can use those type of computers to perform some series of computations. Nvidia is actually like one of the craziest unicorns in the world.
Yeah.
So it's a no-brainer saying that hardware is actually outdated, because that's the backbone of every damn software you're actually running. So since that is the foundation, then I don't think if the foundation is outdated, then there's no future to build on. Exactly. So they are saying hardware is outdated, then there's no software. Even people talk about cloud computing, that you don't need to buy, but at the back end you have servers everywhere that are actually like carrying the request, and they are doing the crazy math for you, they are doing the crazy computation for you. Whereas you think that there's no physical device handling because you think you're in cloud. There's actually no cloud without those servers that I'm talking about. So essentially, your software is actually as fast as your hardware provides you. Is as fast as the computational power your hardware provides. That's just it. Yeah. So yep. Hope I've demystified it, at least your satisfaction.
So if you have any other myths in the comment, you can put in the comment section, and I'll drag into comment and okay, so do you have like any projects that you've worked on or you're currently working on in the hardware field that kept you going, that after, like, apart from the first blinking light?
Okay. Wow, you have to say that. That's fine.
A more serious, like,
so blinking this is not serious.
It's actually something I did not see.
I know, it's okay, sir.
It's actually something,
yeah,
but like
that's okay.
Something like what project?
Something worth it, right?
No, not
okay. It's okay. I just
guys, let me talk to
you.
Maybe you understand. So, do you have any project, like any other project?
You're talking to me, okay? Yeah, it's fine.
That you've worked on before, or you're working on that still makes you like
that still keeps me going.
About
so so what's earlier this year I started something, and which I'm really proud of myself, because I was able to push through it, and that's I entered the field of brain computer interfacing, BCI. So how did I enter this field? So it was during an internship at the research lab in OAU. So we were working on rehabilitation robots, and I saw the power of hardware at work. So the power in terms of the fact that somebody with like an upper limb dysfunctionality can get their limb back up to gear through the use of like the products that we're talking about. So that really inspired me, and I felt like there's so much that can actually be achieved. Okay, so learn C. So after learning C, then you can start learning Arduino programming, which is more like the basic part of it. So after learning Arduino, you have to do projects. Just start from the most basic projects, like see LED blinking. Oops,
traffic lights. Can even do Christmas lights. Last year we did Christmas lights.
Yeah. And don't be like computer students.
Be like us. Start little.
But don't start too little.
So any communities that people can join, because we know that a lot of software communities.
I think the surest bet I will tell you is IEEE. So IEEE is that community, that the Institute of Electronic and Electrical Engineers. So exactly. So it's the E there is actually for everyone. So regardless of your background, you can join IEEE, and we have a student branch in OAU as well. So that's where you find people that are they are really hardware centric. You find the hardware centric people.
You can just reach out to me.
Exactly, you can reach out to me as well. And the fun part is that after attending that particular tech event I talked about, in which students were pitching a lot of fintech products and everything, I had to like organize like a STEM outreach of sorts, so that we bring students from different backgrounds, from different schools together, so that we can do core hardware as well. and that's the beauty of it. So if you don't know something, there's no way I'm going to teach them. So we have to like train undergraduates as well, so that they can be able to like give back to the community. That's how wonderful IEEE USB is. So IEEE is that community that can keep you motivated. We have different tracks in IEEE, and yes, we'd really love to see you guys come around. Yeah, it's a beautiful community. Yep.
Thank you so much for joining.
You're most welcome.
And before you leave our platform, do you have any last words for the viewers?
Yeah, so I think I'd like to leave you people with my 2 favorite quotes. The first is from Samuel Allman, which is like, yes may wrinkle the skin, but to give up enthusiasm wrinkles the mind. So, and the second one is, with perseverance the snail reached the ark. So what do I mean by yes may wrinkle the skin? So it's more like, on this journey of hardware, you will see shaggy, like your components will whine you, but but don't feel jittery. You just need to keep pushing, and yes, you get to the root of the problem very soon, and you need to keep practicing. Consistency is key if you really want to make any headlights. If you really want to make waves in the hardware niche, you really want to work on your social media as well, especially LinkedIn. LinkedIn is that platform that people really underrate a lot. So you don't really need to know anybody or anything. Just do your thing, push yourself out more often.
Look at the views. Look at the likes.
Exactly. The right person will actually contact you. The right person will appreciate your work, and yes, they will ultimately reach out to you based on your skill sets. So you need the skill sets before you can make any move. And yeah, perseverance is also key. At least the snail reached the ark big time. So that has to be one of the slowest of the animals, and it was able to reach the ark. So how much more you have 2 legs, and big time you can even decide to fly. So yeah, you are your limits.
Thank you so much. Thank you guys for watching. Don't forget to subscribe, like, reach out to Emmanuel on LinkedIn. His name is Emmanuel Peter on LinkedIn. And any last word, shout out for our Beyond Code. Hi guys, watch Beyond Code or something like that. That's our channel.
Hi guys, so this is one of the best channels you can actually subscribe to. Just you learn a lot big time. So shout out to Mercy, my very good friend. Nashano also. Actually teach you for the pilot. So yeah.
Thank you guys.
I played that card.